lesson today should be pretty easy as far as new concepts. We have already talked about the letter symbols for most of the different sets, the double-barred letters that we use, so we're not writing out the whole long names. We're going to have some new notation for something we've already learned. So we're just going to do some review problems that use the new notation. So it won't be a new idea of how to come up with the graphs for the problems. It'll just be a new notation for asking the questions. So first, let's review our notation. The double barred N can mean the set 1, 2, 3, and what do we call those numbers? N has something to do with their name. What's the name of that set, Griff? It is the natural numbers or the counting numbers. And if we add 0 to that group of numbers, what do we call it? If we have 0, 1, 2, 3, 4, 5, and so on. Caleb? No? Nicole? The whole numbers, if all we do is add 0 in there, and you don't see it all the time, but some people will use just a W, not really with a double bar on it, but for the whole numbers. Now, Caleb, if I take the opposites of all of those, so 0, 1, 2, 3, and all of the negatives just of those, then what do I have? Then I have the integers. And what letter do we use for integers? That double-barred Z from the German word zahlen, to count. And we also know that we can use the abbreviation Z plus for positive integers and Z with what looks like a minus sign for an exponent for the negative integers. Okay, what about if I throw in fractions? Or if I throw in those repeating decimals that we now know how to write as fractions, or decimals that end that I can write as a fraction. What do we call those? Anything that can be written as a fraction, Wyatt? Not yet. There's a lot more things besides just that in reals. Anybody know what we call them? We call them rational numbers. We can write them as a ratio. We can write them as a fraction. So can be written as fractions. Now, why don't we call those R? What do we use R for? Reals. So why do we use Q for these? No, it's actually a word we use in English. If you can write it as a fraction, Nicole, quotient. Fraction bar is another way of saying you're dividing, right? So you can write this as a quotient. That's why we use the Q, because R is already taken for reals. Then irrational numbers, and you do not see P used very often, but there are a few sources that will use a P. I usually, if I want to abbreviate it, just write IRR. To me, that's easier to remember what it's talking about and everything. Can anybody give me examples of irrational numbers? They're still real. Emily, what we have there, Emily? Pi would be one. Anybody think of any others? Wyatt? E, Yesenia, you thinking of something else? Negative fractions would still be rational numbers because I could write it as -1 divided by 2. Nicole? Square roots of certain numbers. Square root of 4 would just be 2, and it's in all of these sets up here, so it's rational. So how about square root of 2 or 3 or 5, ones that we cannot reduce? Okay, then we have our real numbers. That's when we use the double barred R, and those are all of the above. all of the rational ones and all of the irrational ones. We also have our complex numbers, and those are the things we can write as a plus bi. So that's something that's a real number plus something that's a real number times I. And I, of course, is what? How do we define I? Square root of what? Of a -1 is I. And so square roots of anything negative give us others of the complex, of the imaginary numbers. So just reviewing those. All right, now for our new set builder notation. Set builder notation means we use our squiggly braces on each end, not a parentheses, not a square bracket. Must be the squiggly kind. That means the set of, then whatever's described inside of it. We've been doing problems where we write it in two parts. Here's an inequality or an equation or something, and here is what our domain is. Now we put all of that inside of those squiggly braces. This part means the same as the domain as the integers. We read that as the squiggly braces, the set of numbers x, where x is an element of the integers. That C with a line through it is kind of a very specific stylized E, and it means is an element of the integers. Or we might not actually say all of those words. We might say the set of all numbers x that are integers. Then we get to a vertical bar, which means such that. And then the problem comes after that. X plus 2 is greater than 4, and then we close our squiggly braces. So just a new way of writing it. Now we're going to review several different kinds of problems that have used this notation. So we've got integers, x plus 2 is greater than 4. We start off with our inequality, x plus 2 is greater than 4. Madeline, what do we do now as the next step? Subtract 2 on both sides, so we have x is greater than 2. So integers greater than 2. Allie, would you describe what I ought to now do on my graph to graph that now that I know x is greater than 2 and I'm talking about integers? Like that? Okay, colored in the important part to get there. Oops, didn't mean to have it quite that big. That was x is greater than 2. So color in on the 3, and you said and fill it in, and on all of the others going this way. Need to have at least the 3 and the 4 with dots and a double arrow on the end. I had to do more because my number line went farther than just 4. Questions with that one? Okay, next one here. This time we're going to do an absolute value one. This says we are working with real numbers, the set of all x's that are real numbers. Then this line means such that. And then the problem I need to solve is the absolute value of x plus 3 is greater than 5. Step 1 is get absolute value by itself, so that it's greater than or it's less than. What do I need to do on that, Cooper? What do I need to do first to get the absolute value of x isolated? Subtract the 3 on both sides, so I'll have absolute value of x is greater than 2. Okay, that inequality is greater than, so that means I need to write it with the word or in between my two halves. 1/2, I just get rid of the absolute value bars, because then step 2 is to write it as a conjunction or disjunction with no absolute value bars. Second half, I keep the x. but I turn the inequality and the number, so it's less than, and the number moves from positive to negative or negative to positive. All right. Austin, can you tell me something about how I draw this graph? Okay, yeah, it would be good for me to get my number line labeled there. Forgot this one didn't already have numbers on it. Okay, and actually I like that you were saying since it's real numbers first, because if it were just integers, we wouldn't put any open circles in. We'd just skip those and only do the filled in ones. So you were kind of right to be looking at both at the same time. Now what do you want to do? Okay, so these in here, are those greater than 2 or less than -2? So I don't think I want to shade connecting them. Where should I shade instead? Okay, I'm going to shade the ends. Here are the ones that are greater than 2, so I color those. Over here are the ones that are less than -2, and I'll kind of shade this the other way so I can talk about that. Double arrows on both ends, so we know the number line keeps going and the shading keeps going. If you do them above each other, they might kind of look end to end, or they might just look above each other. If you like to shade right along the number line, you've got to draw it dark enough that I can see it. Don't do it where it just barely goes along the line, because I can't tell if you've shaded anything or not then. Everybody comfortable with that one? Okay, the next one's going to have something that looks pretty weird to us. So I've got my squiggly braces, so I have the set of. But I don't just have an x now, I have a parentheses with an xy. So it's the set of all points. It's a set of all points in the coordinate plane that are an element of r squared. That just means the xy two-dimensional coordinate plane. It means we have real numbers going across, real numbers going up and down, real by real is what the r square means. And then we've been doing ones like this. We've got our two inequalities that now we need to figure out. Y is greater than x plus 2. Y is less than minus x. Jack, could you describe for me how to graph y is greater than x plus 2? Don't worry about the shading yet, just how do I draw the line? Which two? So 0, 2? So 1 over 1. And do I draw my solid line in through all of these points that I'm drawing? Okay, so dotted. So since they're only 1 apart, that's probably good enough for my dotted line. Thank you. Kit, would you describe how I draw the blue line? Y less than -x. Dot, and do I fill that in with a solid line now that I've made my tick marks? Okay, no equal bar on either one, so they're both dotted. That has divided our coordinate plane into 4 sections. We need greater than on the green one. Y is greater than the green line. Y is less than the blue line. We've divided it into 4 sections: top, left, bottom, right. I want everybody to point. Which one do you think we should shade? Bigger than the green, smaller than the blue one. And it looks like everybody is pointing to this section over here. We need to pick a test point in this section, not in some other section, not on any of the lines. Who wants to tell me a good one to use? Wyatt? -7, 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, 4, 5, 6, 7, way over there. 1, 2, 3, Is negative 7, 0 in the section we want? Okay, we need to show that it works in both of these. So for the green one, the y is 0. Is that greater than the x is negative 7 plus 2? Is 0 really bigger than negative 5? So that one worked. Then we need to plug it into our blue one. The y is 0 less than minus the minus 7. What's the opposite of negative 7? And is that really true? Is 0 really and truly less than 7? So our test point worked, so we did pick the right section. So we need to shade it in. And there's our graph. Are we okay there? Okay, that leaves me one last example for today. So again, we have our squiggly braces, so we have our set builder notation. This time I want numbers that are integers, so I don't need that r squared, I don't need the xy plane anymore, such that it's got my vertical line that means such that, and then it's already factored, so I need to get my critical points and do my plus minus work. So if 3 minus x is 0, add x to both sides, and what is that critical value, everybody? So x would be 3. What's the critical value for the other one? So put 0 in the middle, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5, dotted lines on 3 and negative 3. And then we're going to start checking. So let's pick negative 4 here in this section on the left. So if we have a 3 minus a negative 4, do we get a positive or a negative there, everybody? Because it becomes 3 plus 4, so that's positive. And then negative 4 plus 3, positive or negative? Negative, and what's positive times negative? Do we want negative? We want to multiply them and get less than 0, and negative is less than 0, so we're happy with that. So am I coloring in solid or am I using dots on this one? Dots because it's integers. Do I want to put a dot on negative 3? Yes, because I have the equal bar. Need to make sure my number line went at least for negative 3 and negative 4 so that I could have at least 2 dots before my double arrows. In the middle, let's try 0. Is 3 minus 0 positive or negative? And 0 plus 3? And positive times positive is? Did we want positive? So we get to skip over that section. Over here, let's pick positive 4. So 3 minus positive 4, is that positive or negative? So 3 minus 4 would give us a negative. And then if I do a positive 4 plus 3, would that give us a positive or a negative? And negative times positive is? Do we like negatives on this problem? And do I put a dot on the negative 3? And all of them going this way. I need at least the negative 3 and negative 4, so I have at least 2, and get my double arrow in there. Anybody have any questions on this?